Okay, so continuing on with our exploration of forensics, we talked a little bit yesterday about fingerprints. We didn't go into any great depth. We introduced the concept of fingerprints as unique evidence, that everyone's fingerprints are unique and that they can be used to identify someone after they've left a scene. And today we're going to go into a little bit of depth about how fingerprints work, what makes them unique, and how they're retrieved. And we're going to see for ourselves in lab tomorrow whether or not you can actually use them to identify someone. Now, three things you need to be aware of, make sure you bear these in mind, are validity, reliability, and evaluation. In academic language, remember validity is how accurate is the result that you get. Reliability is how often you get that accurate result. Do you get the same result every time? And evaluation is your critical thinking component. Okay, so it's not enough just to complete the lab. Remember that you are eventually going to have to do your project about whether or not you think fingerprints are valid and reliable. Right? So you have to keep that evaluation going. Make sure you're doing good notes, right? And anything you come across that you think is interesting or may lead you to think that maybe it's not valid or reliable, you should definitely write down so that you can work on it later. So as I'm sure you've already learned in the English component of this unit, fingerprinting has a surprisingly long history. And it's been the most widely used form of forensic evidence for the last 100 years, but we have solid evidence that it's been used to identify criminals for several thousand years. We actually still have existing fingerprints pressed into clay tablets that the Chinese, the early empires, talking 4th and 5th century BC, would use to identify burglars. They would catch someone, they'd say, no, I didn't do it, and they'd press his hand into clay, and they'd go into the house and they'd look to see if they could find matching prints inside to identify him. So it actually is a pretty long established practice. Modern forms of fingerprinting was first used to identify a suspect in 1892. It was used to identify a murderer, and we still use much the same technique. We'll talk about it a little later on how to retrieve prints. The big thing that has changed in recent times is how we compare them. In the early days of fingerprinting, the only way to compare a print from the crime scene to an existing print sample was to actually hold them up next to each other. So the FBI had index cards, basically, with sample prints on them of people who had been convicted of crimes. And they had thousands and thousands and thousands of these cards. And police departments around the country would take prints from the crime scene and they would mail them to the FBI. And there was a office in the back full of clerks, and that was literally their job, was to take this card from some police department in America and go into this room full of filing cabinets and compare every single one of those sample cards to the retrieved print from the crime scene to see if they matched. And if it looked like it might match, they would send it over to a lab for further analysis. But talk about a tedious process. Fortunately, the digital age has made comparison much, much faster, much easier. But as you will discover in lab, the process is still not without its bumps. Alright, so how can you use a fingerprint to identify someone? Well, fingerprints have several key features. Depending on who you ask, there are 9 or more things that an investigator would look for, but there are 3 real main features that they're going to use first things. Alright, and those are loops, whorls, and arches. Now, if you look at your own hands, you'll find that most of your own fingerprints are going to be loops. They are by far the most common. About 2/3 of all fingerprints are loop type. Whorls, which is basically a circle or an oval on the middle of your finger, are next most common. They make up about 30% of all fingerprints. So chances are you have at least one whorl on your own hand. Arches, on the other hand, are very rare. It's basically just a small hill across the front of your fingerprint, and that makes up less than 10% of all fingerprints. Actually, significantly less than 10%, like 5 or 6%, as I recall. I mean, they're pretty rare. Someone who has an arch-style fingerprint is very easily identified because 9 times out of 10, they're the only person with that type of fingerprint. And so there are some key features that make people immediately identifiable. And while there are many other features that make fingerprints unique, these are the 3 that we're going to focus on. All right, so how do you make a fingerprint? Making fingerprints is actually extremely easy. Not making fingerprints is quite difficult. And the reason for that is your hands are covered in natural oils. Right? It's secreted through your skin. Your palm, the tips of your fingers are oily basically all the time. The only time they're not going to be oily is if you just cleaned your hands with alcohol. And a couple minutes later, they're going to be covered with it again. It's perfectly natural. Don't freak out about it. Right? It's just a fact of life. And every time you touch something, right, a little bit of the oil on your finger is going to be transferred to whatever you just touched. As you will notice, anytime you touch a phone, every time you touch the screen, you leave a mark on it. Right? And because your fingerprint has high and low spots, some parts will transfer oils really easily, and some parts will hardly come into contact with the surface at all, making a nice, clear outline of the print. You can also deposit dirt if your hands are especially dirty. You've been gardening, you've been working on cars, you touch something, you're going to leave a very clear print. Right? And it's going to be made out of oils and dirt and whatever else is on your hand. Dirty hands leave great evidence. Okay? The prints that you can't see, right, which is the vast majority of your own fingerprints, are called latent prints. Okay? These are the ones that you're really looking for as a forensic investigator. Prints that are clear, such as prints made in dirt, are called patent prints. And they do happen, but if they happened a lot, your house would be completely covered in fingerprints, and that's obviously not true. Most prints are going to be made of oils, which is essentially clear. So those are going to be latent prints, right? And that's what we're going to be looking for in lab tomorrow. There will be no patent prints. There will be a latent print on the item. You have to find it and figure out a way to read it. So one of the most important things to be aware of in fingerprints is the question, are they really unique? And this is going to be part of what your evaluation is going to be. All right? You're looking to see if they are actually accurate, reliable, and valid. And in order to be good evidence to identify a particular person, they have to be unique, because if everybody has the same prints, they don't do you any good. So they have to be unique to each person to be considered a good identifier. And we talked last week about genetic drift. Right? So siblings have the same parents, right? But they're not the same. They're different heights, they're different skin tones, different hair colors, different eye colors, they have different features. They look similar, but they rarely look alike. It's called genetic drift. Right? You play genetic roulette, and everybody gets a different result. But you may have heard the saying that everyone in the world has a twin somewhere, you just may not know who it is. And that is, to an extent, true. Some people who are not related at all look very, very, very similar. Okay? So you might want to think about, if people can look that similar without being related, what other features might they have in common? Does that really affect their uniqueness? Another thing to remember is mutation. It will change your genetic outcome, and genetics control everything. So a subtle change in genetics could lead to a radical change in small features. Okay? So something like your fingerprints, which is genetically a very minor feature, right? A slight mutation from one person to another could create an entirely different print, right? Which was a good argument for them to be unique. Which leads us to the case of twins, right? Because twins, identical twins, are identical. So do they have the same print? Well, let's think about this based on what we learned last week. Right? So identical twins have exact copies of each other's DNA. Genetically, they are completely identical. does that mean that everything about them is identical? Would they have the same prints? Or is there some other factor going on in life that may cause a slight shift? Well, that'll be part of your research later, I think. Alright, so now that we've talked a little bit about fingerprints, let's try to make one. Let's make a sample. Alright, and what you need is a piece of paper and a number 2 pencil. And some of you may have tried this in your younger years. I know I did. And all you're going to do is you're going to take your pencil and you're just going to start scribbling. Alright, and you're going to scribble quite a bit. Make sure you change directions to get some bias. Alright, and what you want is a nice, dark, filled in piece of paper. The graphite in your pencil lead is very soft, gives you a nice soft surface, dark, that you can press your finger into, and it will transfer neatly onto your hand. Okay. Once you have this, it's going to take you a minute, you're going to take the right index finger and you're going to press it edge on to the edge of the graphite, all right, and press firmly, and you're going to roll it around. Okay, and this part you don't really need to be neat. Your goal is to get a nice dark covering of graphite across the tip of your finger, like so. Yeah. See how it's nice and even, nice and shiny? That's the carbon in the graphite. Okay. And actually looking at your print in person, it should stand out to you very nicely, almost metallic. Okay. There we go, nice and even. All right. Now what you're going to do is you're going to take your piece of clear tape, preferably packing tape, okay, not Scotch tape because it doesn't give you enough of the print, but a nice big piece of packing tape. All right. You're going to hold it up. I'm not going to use the tape because you can't see it on the camera, but if this was tape, you're going to hold it up. You're going to take your print, and in this part, neatness does count. Okay. You're going to take the edge of your print, and you're going to touch it to the tape, and then you're going to roll your print across as evenly as you can, and then lift. Okay. Now it's hard to see on the camera, I realize, right, but right there on the paper, hold it up to the light just right, you can actually see the fingerprint. Okay. It's hardly readable, okay, but it is there. Now, for you at home, on your nice piece of packing tape, right, the tape is very clear, and your print will be in black graphite, which means that when you hold it up to the light, you will actually be able to see your fingerprint in exact detail. It's very clear, okay, and you'll be able to identify your own key features very easily. You'll be able to see just by looking at it if you have loops, swirls, or arches, just as it would if you were looking at your own hand. Okay, now make 2 of these. Right, you need 2. One you're going to bring to lab tomorrow. Okay, we're going to use it as part of the lab. The other one you are going to take with you to your other classes. I know you're going to need it for dance, and I believe you're going to need it for English as well. So make sure you hang on to it. If you need another one, you know how to make it. They're very easy, and you're going to be doing an activity after you watch this video, and it's going to go through it in more detail. And you're actually going to get to play with it a little bit and learn how to blow it up and size it down so you can examine the details much more closely. Okay, so remember, make 2. You need 2 of them. All right, now retrieving prints from a crime scene is much more involved than making a sample. Making samples is very easy. And you've actually seen the process many, many times. If you've ever seen a crime show or spy movie, crime movies, you see it all the time. In the old movies, it was always dusting for prints. I'm going to dust this place for prints. Okay, and some guy in a lab coat would go around and he'd brush this mysterious white powder across basically everything in the house. And that powder contained ground up magnesium. It's kind of like ground up graphite. It's very, very soft. It's very, very light, which means if it comes in contact with an oil, it will stick to it. Right? And then you just blow gently across the surface, and anything that's not trapped in oil will be blown right off. So most of the dust is going to go away, and only the powder that is in the fingerprint, it's actually stuck to the oil, is going to stay there. And it's going to give you a nice white outline. So the sample you just made gave you a nice black outline. Dusting for prints gives you a nice white outline. Right? And they're more or less identical. The problem with dusting is that if your hands are fairly clean and you didn't squeeze the object very tightly, your latent print may not be very dark. It may not be very thick. So it's only going to capture a little bit of dust, which means your print that you lift from that may or may not be very clear. It does have the advantage, though, that just like with your graphite print that you just made, a print that you lift from a crime scene using the dusting method, you can actually take a piece of packing tape and stick it into the dust that you just made and lift up a exact copy made out of the dusting powder, just like you just made a few minutes ago in your sample. Right? More modern crime shows like CSI, they always carry these flashlights, purple flashlights, as UV lights. Right? And certain bands of UV light, as we learned a few days ago in our bioluminescence lab, certain bands of UV light will cause things to glow. Right? And fingerprints, because they contain oils and other chemicals from your body, certain bands of UV light will react with those chemicals and cause them to glow. All right? And one of the interesting things about UV light is that unlike visible light, most things don't reflect it. Right? Most things do not reflect UV, they absorb UV. So anything that reflects even a little bit of UV light will glow visibly. Right? So fingerprints, even though they're not particularly reflective, right, they reflect UV in a dim room. You shine your UV flashlight around and they will light up pretty nicely. Right? So long as your room is dark enough, you'll get a pretty good look. The downside is that, unlike with dusting for prints, you can see them very clearly. But retrieving them is a problem. You do know where they are now, you can look at them, but you can't just touch a piece of tape to it and take it with you. Usually what they do is they take detailed pictures with a digital camera, and they develop those later, print them out so that they can use them for comparison. But they don't get an actual physical copy of the evidence. They get a digital copy, which, while it is admissible in court, you can't actually carry it around with you and say, look, this was taken off the man's doorknob. It's right here. You can look at it. All right? You hold up a picture, say, hey, look at this picture. It doesn't have the same effect to a jury. So there are benefits and downsides to this. The method that we're going to be using in lab tomorrow is the cyanoacrylate method. Cyanoacrylate, you are probably well versed with. It is good old-fashioned super glue. And as you've probably noticed, if you've ever used this stuff stinks a lot. It is a very powerful vapor. And remember, it is a vapor because it contains microscopic particles of fluids. Right? And the acrylate in superglue will react with the biochemicals in the oils you leave in your fingerprints. And it will cause them to change color. It's a very interesting effect. You're going to have a lot of fun watching this tomorrow in lab, doing it live. It's very easy. We're going to make a fume hood out of some old shoe boxes because they do stink and the fumes are dangerous. So we're going to make a fume hood first before we do our lab. All right, and then you are going to use our cyanoacrylate to retrieve prints live. And there is a video link on Edmodo for you guys to watch. You can watch professionals actually do this in a lab. I don't want to do it here in my dining room table, okay? But I want you to see it in action first. So make sure that you watch the link. All right, it's very helpful. Okay, now I know some of you are already thinking, hey, I get to take super glue to school tomorrow. No, you don't. Do not bring super glue to school. I have plenty of super glue for you to use in lab. Do not bring super glue to school. It is still not allowed. Okay? And don't think you're going to sneak a tube of it out of my classroom either, because I will be counting. All right? So don't get any funny ideas. All right, so I keep talking about tomorrow's lab, tomorrow's lab. What is tomorrow's lab? So before you left yesterday, I handed each of you a blank slide, and I'd ask you to play around with it. Right? So when you handed those slides back in, I surreptitiously numbered them all, and I jumbled them up in a box. Now, when you come in tomorrow, you're going to be assigned a random slide, right? And you are going to retrieve the prints off of that slide, and you're going to use the print samples that all the students are going to bring in, and you're going to see if you can identify the person who left the print on your slide. Right? That is your goal. You're all going to be using the same method to retrieve the print. You're all going to be using the cyanoacrylate method, but you're going to be free to choose any method you want to compare the prints. All right, so devise the best method you can. There will be a couple of digital cameras available. There will be a projector available and one laptop. I managed to secure you one laptop, which means you're going to have to work together because there are not enough resources for each of you to try your own method. So pool your knowledge, pool your creativity, and see if you can generate a method that is accurate, right, and efficient, time efficient, because you have to complete the lab within usual lab time. And since you are going to be using part of that lab to retrieve the print, your method is going to have to be pretty effective. All right? And just like in a real crime scene, all right, time is of the essence. You have to identify the person fairly quickly before they escape. All right? So your goal is to retrieve the evidence and identify the person it goes with before the end of lab. All right? I'm looking forward to seeing you guys and what you come up with, and we'll see you tomorrow. Don't forget, 2 samples. We need 2 of them. One for lab, one for your other classes. Also, once you've done the activity on the Edmodo page and watched the video, I want you to write a short, quick write, just a paragraph, about how valid you expect the fingerprinting method to be. Right? How effective is it going to be, based on what you know? Right? It doesn't have to go into a lot of detail since you haven't done the lab yet, but I just want an honest prediction. What do you think is going to happen? Right? And don't forget to bring in your daily journals. We'll be checking those today, or tomorrow, I should say. Make sure you're taking good notes. So if you are falling behind on your notes, you have fair warning that you need to catch up before I see you in the morning.